Welcome back to the Science Basement. In this video, we're going to explore solubility. At the start, it's important to define a few key terms so that we can understand how to talk about solubility. The first is, of course, solubility itself. The easiest way to define solubility is that it's the ability of a substance to dissolve in another and form a solution. If we look at that more closely, you'll see that solubility is basically a combination of those words, solution and ability. So we get solubility. Next, we have solvent. A solvent is the substance that does the dissolving. In the case of hot chocolate, for example, the solvent would be the water. And lastly, we have solute, which is the substance that gets dissolved. In our previous example of hot chocolate, the hot chocolate mix would be the solute. Overall, water is a great example to use when talking about solubility in dissolving substances, and is one that we're likely most familiar with. But what actually happens when we dissolve something in water? Let's look at salt as an example. If you pour salt into water and stir it, you would notice that the salt fairly quickly disappears. We know it's still there though, because if we were to taste the water, it would be salty. Let's take a closer look at what goes on when we dissolve salt in water. Water is a molecule made of 2 hydrogen and 1 oxygen atoms, hence the name H2O. Water has a pretty unique molecular structure, and to me it reminds me of a head with 2 ears on top. One of the things that happens because of this molecular structure is that water naturally develops a small polar charge, kind of like a magnet, with the hydrogen side becoming more positive and the oxygen side becoming more negative. Water becomes polar because the electrons that are shared between the hydrogen and oxygen as part of their covalent bonds tend to be hogged by the bigger and stronger oxygen atom. Because electrons carry a negative charge, that means the oxygen side of the molecule becomes slightly more negative and the hydrogen side becomes slightly more positive. Because water is a polar molecule, it's able to dissolve other polar substances such as ions and other polar molecules like itself. Water is so effective at dissolving many different things that it is often referred to as a universal solvent, but it's not truly universal because there are some things that can't dissolve in water, like oil for example. Now back to our example of water dissolving table salt. If we were to look closely at a cup of water, we would see the water molecules moving around freely. When we put a salt crystal into the water will act as a solvent and the salt as the solute. The water molecules will start to pull the sodium and chloride ions off, with the positive side of the water molecule removing the negatively charged chloride ion, and the negative side of the water molecule attaching to the positively charged sodium ion. The sodium and chloride ions will dissociate until they're completely dissolved, meaning that each individual atom has been removed and has formed a perfectly mixed solution with water. This is key to what dissolving is. That is, each individual molecule or ion is surrounded by water. If that doesn't happen at the molecular or atomic level, then that substance doesn't truly dissolve in water, but may just form a suspension, like if we were to mix flour and water, or a colloid like milk and water. They mix with the water, but if you were to look closely, you'd see larger particles floating around, not individual molecules or ions. The reason why certain things like oil are not soluble in water is because they don't have positive or negative charges for the water molecules to interact with. When this happens, that substance is said to be insoluble in water. The ability of solutes to dissolve in solvents is critical to life on Earth. If we break it down, you can see why. Let's start with our bodies, for example. Our bodies are about 60% water, and we use solubility for many processes. For example, our digestive systems carry nutrients into our bloodstream and throughout our body with water, then use water to remove waste. Plants need water not only for the photosynthesis process, but to transport dissolved nutrients to the roots, into the plants, and throughout their tissues. Liquids aren't the only things that can dissolve other substances. Every time we breathe, we are breathing in a solution of gases that are dissolved in each other. These gases are about 78% nitrogen, 21% oxygen, and about 0.04% carbon dioxide, or the composition of the atmosphere. Solubility is an amazing scientific principle and can be easily tested at home or in the classroom. Gather up some common ingredients like salt, sugar, flour, baking soda, cornstarch, or others, and mix them with water and observe what happens. Which ones dissolve and which ones don't. See if you can figure out why or why not, and leave your observations in the comments below. And of course, if you like this video, make sure to give it a like and subscribe to the channel to be notified of future content. Thanks for tuning into the Science Basement.